So hello and welcome to lecture 29. So as you can see, this is being recorded in a slightly different way from the other lectures that I've recorded for this course. And there's a couple of reasons for this. Firstly, just sheer lack of time. I just didn't have time to prepare all these lectures over the summer and record them in the other way. But I also thought that this is a good opportunity to try a different way of recording the lectures. With the sort of the disembodied voice and the screen capture thing. And so what I'd like you to do when you respond to the kind of feedback questionnaire on this course is tell me which way of recording lectures you prefer. I mean, I personally much prefer the sort of person in front of the projector screen approach rather than the disembodied voice. But if you really like disembodied voices, then let me know in the feedback questionnaire. In this lecture, I'm going to introduce you to Node.js and Express, and these are the technologies that you're going to be using for the third piece of coursework, where you're going to be building a single-page web application. So I'm going to start off with a brief introduction to what Node.js is. Then I'm going to explain how you can get it running, both using the portable version and using WebStorm. And then I'm going to show you how to build a simple web server that you send, get, post, put whatever to it, and it sends back a simple bit of text. Then I'm going to show you how you can extract useful information from the URL, such as the query string and the path, which you can use to control the information that's sent back to the user. Then I'm going to show you how you can use this data to dynamically generate HTML pages that you send back to the user. Now I could kind of extend, the basic Node module sort of indefinitely really to serve up static files and so on, but instead I'm going to show you how you can use Express, which is a very nice sort of add-on module for Node that will really sort of save you a lot of time when you're building your web application. I'll show you how to build web services with Express, and then I'll show you how to build a simple web application using Express that combines web services with statically served content. Rightio, so Node.js. So far in this course, you've written a lot of JavaScript in the browser, right? You've written a game, you've done some registration, login stuff in the browser. And here you're writing JavaScript code, and the JavaScript code specifies how the contents of the website should change. So, the JavaScript code says, you should be loading these images or whatever for slideshows, showing you how the spaceship should move if you're doing like a spaceship game, and so on and so forth. And in coursework 2, you've even been loading some data from the server using Ajax with JavaScript. So here you have the JavaScript code. The JavaScript code's passed is loaded by the browser. The browser works its way through the JavaScript code, and depending on what the JavaScript code specifies, it makes appropriate changes to the interface. And what Node.js is a modified version of the runtime from the Chrome browser. And this enables JavaScript to be run without a browser. So obviously Chrome is a browser, it has a runtime inside it that executes the JavaScript statements. And what the people who built Node did is they took out that runtime and they made it a separate application so that you can run JavaScript outside of a browser. So Node is kind of, I think it's called headless, in the sense that you don't actually see anything when you run Node. It's just like executing in the same way that you would execute a Java program. And by taking the runtime out of the browser, you open up the possibility of doing many things with JavaScript that you couldn't do when it's just running within the browser. The most usual application is to build servers using Node.js, but you can also do things like robotics, Internet of Things, and so on and so forth. Anything that a normal programming language such as Python or Java can do, JavaScript when it can also do when it's running in Node.js. So in the browser, JavaScript's mostly event-driven. When the user clicks on stuff, or when the window loads, or when a message comes back from the server, it triggers events, and then you can set up JavaScript so it can handle those events and execute different bits of code. And JavaScript in Node works in a similar way, and this because event-driven sort of programming is sort of very efficient, that the code's not doing anything unless a particular event is triggered. That makes it easy to build, nice, scalable, high-performance servers. So Node is every bit as good as, Apache, or one of the other servers that are out there. So just to give you a sort of slightly bigger perspective to understand, what Node is, just like to briefly explain the differences between the other programming languages. So with C++ and C, these are, you write the sort of text files or whatever in C++ and C, and you put them through the compiler, and the compiler converts the C++ and C kind of high-level kind of descriptions of high-level programming languages directly into machine code that's executed by the CPU, which is basically a bunch of numbers that specify sort of instructions, and the CPU looks through those numbers and carries out certain operations. So the C++ and C converted straight to machine code that's executed by the CPU. Java's a little bit different. Java's compiled down to bytecode. Now bytecode's similar to machine code, but the bytecode, the Java bytecode's executed by a Java virtual machine, not by the actual CPU. So the Java virtual machine's a program that runs on the CPU and interprets the bytecode and then does particular things depending on what the bytecode specifies. And that's what gives Java the ability to run on lots and lots of different types of devices. So you can run Java on, Raspberry Pi. You can run it on, some kind of, well, maybe not a supercomputer, but maybe a supercomputer. But also standard, Windows, Mac machines, whatever. You can write the same set of bytecodes as being interpreted by the Java virtual machine. And as long as you've got a Java virtual machine for your architecture, you can run that bytecode. And then we have PHP, which you're doing in coursework 2. And there you have it's executed by the server. So the server is again a program, written in some programming language, and then that server sort of interprets the statements of PHP and does whatever, does appropriate things. And so JavaScript's a bit like PHP in the sense it's a scripting language. It's not compiled down to anything, but then it's being interpreted by a program, and this program can be a browser, or the program could be Node.js. So some of the advantages of Node.js, well, if you're a big company, it's often very convenient to have the same programming language on the client and server. So a number of reasons for that. One reason is, personnel, right? You only have to hire, if you're using Node on the server side and the client side, you only have to hire JavaScript experts, right? And the JavaScript experts can sort of move between the client and server, writing code as appropriate. It also means that the people working on the client and server will find it much easier to communicate and talk to each other. A real other benefit of this, from a corporation point of view, is it's very easy to move functionality between browser and server. So if you have some some functions or whatever running client side, and it turns out that they're just too slow for the browser, then you can move them onto server side and then add some kind of use WebSockets or Ajax to pass the appropriate data to those functions and run those functions on the server. And likewise, you might be able to optimize your server usage by passing off some of the CPU execution stuff over onto the client side. So you can easily move functionality between browser and server once it's written in, if it's written in the same programming language, and that's the great advantage of using Node. And also a number of frameworks exist that can work across browser and server. Again, it's all pure JavaScript, so where you put the functionality is, can be a sort of an engineering choice rather than being constrained by the programming language. Node is, as was explained earlier, it's scalable. It can deliver high performance. Obviously, at some point you have to use caching to deliver your web service, but in general, it's every bit as good as any of the other servers that are out there. Lots and lots of people have written, third-party modules. So if you need a particular bit of functionality for Node, maybe you're doing Internet of Things work, whatever, there's almost certainly going to be a module out there written by someone that will do that for you. So, you've heard me moan a little bit about, PHP in the lectures on PHP. There's PHP websites called, like PHP Turtles, PHP Sadness, PHP WTF, right? PHP, I find, is an absolutely horrible programming language. I can't stand it. I think there's valid reasons for teaching on this course, but I don't like writing PHP. The dollar signs drive me crazy. It's just plain ugly, really. Whereas JavaScript, I think, has its quirks. No programming language perfect. It's got this funny stuff with prototypes that really, who cares, right? But, the basic core language of JavaScript is a beautiful scripting language, in my opinion. And so it's really nice to work with. So if you use Node server-side, then you can just write your entire web application in pure JavaScript. And I think that's a major advantage of it. And if you're working on a big project, tens of thousands of lines of code, you're going to have less problems if you enforce types, for example, and so you can use TypeScript with JavaScript. There are also ways in which you can compile more advanced versions of JavaScript down to to make it work with the browser. There's a bunch of really cool tools with JavaScript. So in general, working with JavaScript is a good thing. Another advantage of Node is that it opens up many other applications of JavaScript. So there's various web testing frameworks based on Node. You can use JavaScript running on Node for robotics, for the Internet of Things, and so on and so forth. So it's got many other applications open up once you're using JavaScript on Node. Right, so I hope I've done the cell on Node. So now let's have a little look at how we actually get it running. So as is usual in this course, I do my best to support the lab machines, and the easiest way to support the lab machines is to provide a portable version of Node. So maybe in the future I might look into getting WebStorm installed on all the lab machines, but for the moment we're stuck with these portable versions. And so what I recommend if you want to use Node on the lab machines is that you download the portable version of Node, unzip it onto your USB stick along with all the other stuff on your USB stick, and then you can just run it from your USB stick. And this works fine, but if you've got a laptop, I recommend you download and install the proper version of Node, because it's going to be more up to date, and it'll work nicely with WebStorm, which I'll come to in a little bit. So the portable versions, this is version 5 or something, and now we're into version 8 with the sort of full commercial version. What was I going to say? Oh yeah, and obviously if you're downloading and if you're running everything from your USB stick, it's your responsibility to back up that USB stick to the cloud. As I've said to you many times, zip your project up, email it to yourself, or upload it to your OneDrive, possibly with a date on it, so you could do some versioning, or use proper versioning, right? Use GitHub or something like that, right? But back it up somehow, because I never accept, I lost my USB stick as an excuse, okay? You're second year computer scientists, you can take responsibility for looking after your data properly. So, if you're not using the lab machines, you're using, a Mac or using your own laptop, then what I recommend is that you actually install Node.js, and you can install and download and install it for free from the official website. Now, the installer should add Node.js to the path, or you might have to do this manually later, depending. If you have an option in the installer to add it to the path, add it to the path, because I'm almost certainly that's going to make it easier to work with WebStorm. So once we've installed Node.js, we can then run them in two ways. Typically we can run them on the command line, or we can run them within an integrated development environment. So I'll just show you how to do it on the command line, because this is what you're going to have to do if you're using the portable version of Node. So what we do is we create a JavaScript file with the extension .js, like hello world.js, something like that. Then we launch the Node.js command prompt. We navigate to the location of the file. We type node hello world.js, so just telling it to, this is like a bit like Java, right? You say Java, and then whatever you're executing, right? So we're telling Node to execute, this is the Node program, telling it to execute this JavaScript file we just created. And if Node.js is on the path, we can do the same thing within PowerShell or whatever, if you're running it from a machine where Node's been installed. So I'll just show you how to do that. So let's just go, so here's my USB stick I'm using for this demo. So here we have Node. This Node folder contains the unzipped version of the portable version of Node. And here's the sort of launcher for launching up the command line. And then we have the Node, what I called Node www, you can call it whatever you like. So that I just wanted to keep it separate from my www folder, which is configured to work with Apache. So I just wanted a separate folder that's going to hold all my files from my website. So we go into this folder and we do new text document, and let's call it, let's go for the hello world.js. So we want to change it, right? So here's my file that I want to create. So we're going to open that up with Notepad++. This is the sort of primitive version of things here. And so here we have Notepad hello world.js, and all we're going to do is console.log, hello world, right? It's a classic, yep, hello world. Put the exclamation mark in just for a bit of human feeling. Right, great. So we have our console.log, so that should just output hello world when we run it. So now if we go back to my USB stick and go into my Node folder, I want to start up this Node portable, which should start up a command prompt that will let us then execute Node, use Node to execute the script that we just found. Now, unfortunately, this command prompt in the portable version of Node is this sort of old MS-DOS thing. So you have to use like dir to list stuff, and it's not the most fluid and easy to use shell. But never mind, we'll go with it. So I think most of the stuff works. So we go up. So what we're doing here is navigating to the directory where I've got the file. So I'm just going up a couple of directories, and then I can do dir again, and we can see here's our folder that we want to get to. So we go into node www dir. We can then see here's our hello world.js that we've just created and edited. And now to execute that, to run that, we just do node hello world.js. And it's not a particularly spectacular application, but you can see here that it's output hello world, which is the what I wanted to do. So this approach works. You can run the examples. I've tested the examples that I've given you in the rest of this lecture using this approach, so you can run it. Should all run on the lab machines. If it doesn't, let me know and we'll sort it out. But I don't think this is a particularly fun or friendly way of developing Node applications. So we're not going to use that for the rest of this talk, and I'm going to show you a much better way. So I'm going to exit out of here. I'll go back to our thing here. So what I'm going to show you now is where I can use a JavaScript integrated development environment. So you've used IDEs before, right? You've all used NetBeans. Brackets is kind of a bit like that, sort of, because it kind of runs the stuff you're executing. And there's many other ones, okay? And so the thing is, though, things like brackets, Sublime Text, Notepad++, well, firstly, Notepad++ is not an IDE. But anyway, we can use these kind of things to write JavaScript and execute it on the command prompt, right? So I could use brackets to write my JavaScript and execute that JavaScript in exactly the same way I've shown you just now. But the problem there is, you've got to keep switching between the command line and the integrated development environment, and things like Notepad++ aren't really, they're okay, they'll do the syntax highlighting, but it's not, it's not an ideal way of developing Node applications. The good news is, though, that there are integrated development environments that are actually designed, to work with Node, to work with JavaScript. And the one that I've tried, when I did a little bit of research, WebStorm came up quite favourably, and I've been playing around with it, and I think it's an absolutely fantastic way of writing Node web applications. So there's the link there. What you have to do is you have to register using your Middlesex email account. If you register with your university account, you should be able to get free access to WebStorms, and that's what I'm going to use for the rest of this talk. This is WebStorms. So you can see it's pretty nice. It's like most of these things, except that it's really set up to work with Node. So you have a bunch of, all your external libraries or whatever here. All your files here, and then you sort of edit them here, and then you sort of click on the green button to run it, and then then it runs it, and it's all kind of built into the same application. So it's very easy to do debugging and stuff like that. Whereas with Notepad++, debugging is going to be a bit of a nightmare because you don't even have the Chrome tools available with Node, right? Because you're not running it in the browser. So if you want to do proper debugging, you need something like WebStorm that can understand how to sort of step through lines of JavaScript when it's executing it on Node. So I recommend, if you're going to tackle coursework 3, that you give WebStorm a go, and I'm pretty sure it's available for lots of different operating systems. So let's do the same thing with WebStorm. Okay, so let's so here we have WebStorm. So let's create a new project. So here on the left we've got our various files. So let's create a new. Let's just add it here actually. So we should right click and we say we want new JavaScript file, for example. We'll call it demo2 because then we've already got a demo1. So we have a nice sort of empty JavaScript file. Type console log, and you can see it's got all this nice sort of suggestions of different functions and so on and so forth. We'll call this hello world from WebStorm. Slightly pretentious name, but never mind about that. But anyhow, so I've actually got something running, so kill that. So exactly the same thing, and here we right click, run demo2 because it's got sort of set up various run configurations, and this probably is not set up yet. So we just right click and run demo2, and off it goes, and it runs demo2. So we actually didn't see what was going on there, so let's get up the no, I didn't want terminal. Of course, now I'm getting a bit stuck with the I'm a bit of a WebStorm newbie, should I say. Let's try running it again. All right, I think I've minimized everything, that's fine. Great. So, in case you missed it, we'll just press play again, and all it's doing is it's running it within Node, because it's got the path to Node here, and it's outputting hello world from WebStorm. So as you can see, everything is built in. You just press the green button, or there's a keyboard shortcut, and it will straight away run it. And it has an easy way of relaunching a server once we get into the server stuff, which makes it all very nice and easy, and we can see all the error messages there, and it's all nicely built in. So strongly recommend if you're doing Node development, WebStorm's a pretty good option. Right, so we've had the hello world, we've got Node running. Now let's actually start building web servers, because that's what this is all about, really. So in this section, I'm just going to show you how you can use the built-in modules to create a simple web server. And later, I'm going to show you how you can use Express to take a lot of the pain out of that process. And Express makes it very easy to build like a web application that combines web services with statically served web pages. And I'll give you a sort of final demo at the end of the talk, bringing all of this wonderfully together. So for the simple web server, we're just going to use the built-in modules for Node. So pretty much every programming language doesn't have all of the features available at once, immediately, within a single program, right? Within Java, you have to import the particular packages you want to use of the program. Same with C++, right? You have to include the headers and link to the libraries and all this kind of stuff. And Node's no different. And so here in Node, we have to use the require statement to say which of the libraries we actually want to be using, or the modules, which modules we want to be using in this application. So if we want to use the HTTP module, which is what we're going to use for serving up for our simple web server, we just do require HTTP. Then that returns a variable, and this or object, which is typically a sort of object or a function, and then we can do all the things that we need to do with this object or function within our application. And you can also create your own modules and link to them in your code. Now the HTTP module is a very sort of basic HTTP server. And so if you've ever played around with writing HTTP servers in Java, there's a HTTP server package in Java that does exactly the same thing. It sort of sits there listening on a particular port, and then it has various methods for handling, get, post, put and delete requests sent to it. But it's a very sort of stripped down server. It won't serve up static files. It won't do very much else for you except do the listening and respond to get, post, put and delete messages. So to use this server, the Node server that is, we do HTTP create server. So I said the HTTP variable is an object with a bunch of data fields and methods. And so we're doing create server to build the server. And what we do is we pass a function into this method, and that function is executed when the server receives a HTTP message. So we set up the server, and then we start the server listening. Here we're specifying the port that we wanted to listen on, and then that's it. Off we go. So here's the basic code. So at the top here we've got the bit I just explained, that we need to use this require keyword to specify that we want to use the HTTP module, and then that returns this object, which then has all the functionality of the HTTP module. Next part of the code is this send response. That's just a name I've given it. You can give it any name you like. It's just a name for the function. And this function has two arguments. It has a request argument and a response argument. We use the request argument to pull out information about the request, and I'll show you a little later how we can extract information about the URL of the request and the query string and all this kind of stuff and the path. And we use the response to send back the data to the user. Yeah. So for example, in this very simple example, we're using the response. We're like writing a header saying it's 200 meters, like the HTTP status code for OK, and then we've got we're saying that the content type of the message is just a text content, right? It's not image or some weird stuff like JSON or whatever. And then we need to do response.end. If you don't do response.end, the client won't know that you've actually finished sending back the message, and it'll just sort of hang around forever and gets kind of messy. So you need to end your response in some way. So after you've written a bunch of stuff, you need to do response.end. In this case, I'm combining writing stuff and ending the response by doing response.end here with a bit of text, just saying hello world, right? Next bit, I then need to create the server, and then I create the server with the function that I've just written here. So I'm saying that when the server receives a request, it needs to execute this function, and it'll call this function with these two arguments, and then I can use the the information here to send back the appropriate response. And finally, I need to set the whole thing up listening on a particular port. So 8080 is like a standard port, but I could pick some random 8056 or whatever. If for example 8080 is already in use on that computer. Now, in some of the examples you'll see online, it looks like this. So I've written it like this to make it as clear as possible for you, just so you can actually understand, this is the function, it's being passed in, and we're starting the thing listening, all the rest of it. But you often see this kind of syntax where we just we get the module, and then people like writing things in single lines with anonymous functions, which is fine, it's correct, but I think it can be a little bit confusing if you're just starting off with this stuff. So here we have just exactly the same thing as this. We're kind of creating a server. Instead of specifying the functions separately, we're passing in the function as sort of anonymous function here. So this is the function that we had, in the previous example. And then the create server will return the server object, which will have a method listen. So we can just sort of tack on the listen at the end if we're obsessed with creating like multiple kind of calls all in this kind of line method. So I don't think this is particularly clear, but some people really go for the syntax. So just don't be freaked out. This syntax is exactly the same as this syntax. Yeah, it does the same program, just slightly different way of writing the same program. And with a bit of luck, when we run our simple web server, we will get this hello world message. So this is a little demo. So let's go for WebStorm. So here we have, where's my little simple web server? So here's my simple web server. Everything I said is just as I explained, so I don't need to go over that again really. Going to run it here. So what we can see here is now we can see it's running. Okay, with the previous example it just ran and then executed, whereas with this simple web server, the play button's gone away and it's been replaced by this kind of refresh type button. So I can stop it running with this button. That probably gives us debugging stuff. And this can, if I want to relaunch it, if I want to change the code and then relaunch it, I can just click on this and it'll relaunch the server, very quickly, as you can see. So now we've got our server running. We can then go to here and we type in HTTP localhost 8080 because that's the port that we're using. And if we just go to the root of that, it gives us the hello world message here. Very nice and easy. And to show you how we can change things, so if we want to go for hello world 2 or something, we can just relaunch it here, refresh it here, and then we can see the modification there. So we can change it and then refresh it in here and we can see exactly how it's changed. So the browser is sending the HTTP request to the server and the server is responding with this text, hello world. Right. So the next thing I want to cover is how we can pull out some useful information from the URL and use that information to control what we send back to the user. So as I explained briefly, the request field contains the URL of the request, the complete URL. So this is the sort of complete sort of URL. So there's the sort of URL. It's a little bit ambiguous because you'd have thought this was the URL, but this is like domain name or something like that. You can pull that out of the request as well, I'm sure. The URL sort of, in this case, means everything after the kind of domain name and the port and all this kind of stuff. So if you want to access this URL, it's very easy. You just do request.url. That field contains all of this stuff that's being sent to the server to request a particular page. So we do localhost 8080, and then we echo out the URL. Then we get the URL is like my path, query, blah, 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 blah. Now the query string is a bunch of key value pairs separated with ampersand that's appended to the URL. And just a general tip, don't put any spaces. If you use query strings, don't use any spaces in them. Okay, maybe I think an underscore is okay. Not certain about a dash, but just stick to. Ideally, don't have any spaces or funny characters at all. URLs are very limited in terms of the range of characters, and you have to do all this kind of escape character stuff, and it's a whole, there's a lot of potential for mistakes once you start using spaces in your query string. So stick to things without spaces or without funny characters, and you'll be okay. So at the end of the path or path name, whatever, you have a question mark, and then a bunch of keys and values. So in this case, the key is Q and the value is cats. And if we wanted some more like key value pairs, we put an ampersand here, and then a bunch more kind of key value pairs, all separated with ampersand. And that's the query string. Query strings typically use GET requests. So in this case, I'm showing a Google search. So we're getting some information from the Google server in this case. If we were sending information to the user to the server, for example, from a form or something like that, then typically the key value pairs will be packed into the body of the message. As those of you already working on coursework 2 will know, right? You have to sort of pull it out from the PHP post field, right? Which is a separate place, whereas the query string stuff all goes into the get field. And this query string is extremely useful because then we can control the data that's sent back from the user. In this case, we can search for cats, we can search for dogs or mice or whatever, and depending on what we put here, we can search for different things. And these kind of query string used for GET requests, is absolutely, and has many applications, right? Shopping, we might be searching for different kinds of products and so on and so forth. And the thing about GET requests and query strings is you can bookmark them, right? I can bookmark the Google search for cats, and then return to it at multiple points, or pass a link, to my friends. Hey, look at this search for cats. Look at those cats. Those cats are amazing, kind of thing. So, if we want to extract the query string, we could do a lot of messy string processing, and look for the question mark, and then fish out the key value pairs using maybe a regex or something like that. But instead, Node has this lovely URL module that will do all that hard work for us. So the URL module will process the URL, and we can then extract from it a JavaScript object that contains these key value pairs in the query string, which makes it much easier to pull out the data that we need. So I'll just show you how to do that. So firstly, we need to require this URL module because we're sort of importing it and using it in our application. And then here we have this the function that's executed when the server gets a GET request in this case. And so first thing we want to do is get the full URL out of the request. So this is very longhand because I'm trying to show you the steps in the operation. Obviously, you probably put that request URL in here. But to show you the stages, I've sort of broken it down into separate variables to make everything as clear as I can. Okay. So here we have a variable temp URL, which holds this will hold the full URL. And then we do URL.parse, and what parse will do is it'll convert this temp URL. It'll take that sort of messy string and convert it into a nice object that contains all the fields that we need to get out the query string and other bits of data. And then if we want the queries object is stored within this URL object using the query key. So then we just do URL object.query will return another object that contains the key value pairs in the query string. And now what I've done in this example is just output them. So I'm working through all of the keys in this query object. I'm just outputting them so we can actually see them, and then I'm finishing off and closing the response so that the browser doesn't get confused. And so if we run this and put in this path like name equals Brian and age equals 87, then you can see that it's outputting like the key, which is name, and the associated value of Brian, and another key is there, which is age, and another value which is 87. So it's out. So we've extracted the information from the query string using this URL module, and that's making our lives much easier. We can also extract the path from the URL. So the path is the sort of stuff after the domain name and before the query string. So in this case, the path is like catty, and so very easy to get out. Again, we have this URL object that we get when we use the URL module to pass the URL, and this URL object has the query, which I've just described, and it also has a path name, which then we can use that in various ways. So I'll just give you a little demo, show you how it works. So here we have, where is it? Yep. Here we go. So this is exactly the code that I just showed you. Let's just open up a little bit. Yeah, nothing's, So in these examples, I'm typically showing this stuff that differs from the simple server. So I haven't bothered showing you, the creation of the simple server and so on. Just the main bit that changes in each case. So let's stop that. Let's run this thing, URL query string demo, and go to our simple web application, So who knows, maybe it'll crash. Yeah, so in this case it's fine. So we haven't got any path here, but if we haven't got any query string, right? So if we had a path, you know, cats, dogs, mice, then you can see that that's the path that's being sent to the server, and you know, cabbages or whatever. So in this case, the path isn't corresponding to any kind of folder structure on the server, right? If we were serving up static files, the path might correspond to folders on the server, but in this case, the path doesn't correspond to any of that. It's just part of the URL that's being sent to the server. There is no folder structure that corresponds to cats, dogs, mice, cabbages. In this case, we can, and so we can use the path to load up files from subfolders and so on. But we can also use the path to pull out particular bits of data from the database, or do different kinds of response back to the user. So I'm going to show you in my web service example how we can use the path to control the data we're being sent back in a similar way to how we could use the query string to do that. Anyway, so let's go back to, let's do cats, dogs, mice, whatever, and then we can add some queries if we liked. So here we have queries, you know, name equals Andrew. So this is a, you know, whatever. So now we've got a query, name value Andrew, you know, age equals 5, let's say. So you can see that my code, in the example code, is pulling out, wait a minute, that's wrong, it should be an ampersand. There we go. So we've got a series of key value pairs, and the URL module is pulling them out nicely so we can use them. And we can also pull out this, and I'll show you how we can split the path if we need to pull out like the last directory or something like that. Okay. So this URL, path, and query string information can be very useful for delivering different pages to the user. Now, as explained, we can load these pages from the file system. So the path in this case could correspond to folders on the server's file system, or we can just use that data to dynamically generate different bits of data or control what we're sending back to the user. Or using data from a database, for example, as well. We can have, you know, products, hats or something, and that wouldn't necessarily have to correspond to a folder in which there was lots of pages about hats. It could just be used to search for the database for hats and then send back some pictures of hats to the user or whatever. So we can use this URL information to deliver web services, and I'm going to explain that in a little bit. Right, so I've explained how we can use the query string and the path, or how we can extract the information about the query string and the path. Now I'm going to give you a very, very simple example of how we can actually serve up, you know, one of two web pages depending on the information contained in the query string and the path. So the simple server, which I started this talk off with, receives an HTTP request on port 8080 and replies with some text. Now this text was just plain text, didn't have any HTML tags. It wasn't what you might call a proper web page. So it wasn't written in HTML. So in this example, I'm going to show you how you can return a dynamically generated web page that's actually written in HTML. So in your previous piece of coursework, you've already done this quite a lot. In coursework 1, you've dynamically generated some HTML, for example, when you did the rankings table, because you had to kind of wrap the data, the user score data and the usernames in some HTML and then inject it into the page. That's kind of dynamic generation of HTML. If you've done coursework 2, by the time you're watching this lecture, you'll have done lots of dynamic HTML by wrapping data from the database with HTML tags and returning that to the user. In this extremely simple example, I'm just going to use the path to select which page is returned from the server. So in this example, I've got two HTML pages, which I'm calling page 1 HTML and page 2 HTML. So this is basically a very sort of minimal set of HTML for a particular page. Now note that WebStorm has the beautiful ability of doing syntax highlighting within quotation marks. So, you know, even though this is in quotation marks, it's still telling us about the tags and all this kind of stuff, which I think is, you know, a fantastic feature. So here's our send response message. As I said, you've got the server setup stuff's all the same. So here we're getting the path name by using our URL module here. And what I'm doing here is I'm saying if the path name's page 1, if the user's requested page 1, I'm going to respond with the HTML for page 1. If the path name equals page 2, I'm going to respond with the HTML for page 2. and otherwise I'm going to say path's not recognized. So the user can request different pages from the server, and depending on the path, I'm going to reply with different chunks of HTML corresponding to those two pages. So again, nothing to do with database, nothing to do with the file system. I'm dynamically returning different pages to the user based upon the URL that they're sending with the request. So if I request page 1, I get this hello from page 1 HTML. If I request page 2, I get hello from page 2. And if I request a page that's not recognized, a path that's not recognized, then I get an error message. So give you a little bit of demo. This is fairly obvious stuff, I hope, but I think it's worth presenting for the clarity. So this is the full code here. So here we have the modules that we're linking to here. Our two pieces of HTML corresponding to page 1 and page 2. And then, depending on what the path is, I either write back page 1 HTML or I write back page 2 HTML. So let's stop the current one and run the new one. If you don't stop it, the previous one, and start running the new one, then you get a port conflict. So just be a little bit aware of that. So let's go back to, so this is going to give us a path not recognized, right? Because it doesn't recognize cats, dog, mice, or whatever. But if we type in page 1, then we're getting the data from so this is a complete HTML page in this case. We're not just replying with text. This is like got the header and the HTML tags and all the rest of it. So then we go to page 2, and it's replying with a different page. And then if we go for page 3, then it's path not recognized. So I hope you can see from this that we can use the path to reply to control which dynamically generated HTML page we send back to the user, and that's the crucial point I'm trying to make. Okay. So we could build our entire website using dynamically generated HTML, and that'd be fine. I could reply, have a sort of CSS path, and then I could reply with a sort of CSS, dynamically generated CSS. We could build an entire website using that approach, which is partly why I've sort of shown you that approach. But it would be a bit of a pain, In many ways, in many situations, most situations probably, it's easier returning static data stored in files back to the user. So we might have some JavaScript written for the front end of the website. Yes, we could, return it in exactly the same way we return page 1 and page 2, but it would be kind of a pain. It's much easier to develop that JavaScript on a text file and then serve up the contents of that text file to the user when they request it. Same true of CSS, and particularly true of images, right? You don't want to mess around, writing all the bytes or whatever it is, in your Node source files, right? We're going to put the images in a folder on our server, and we want that server to reply with those images. Now, we could add all the functionality for serving up static files to our simple server, right? We could use, various Node modules to load up contents of files from the file system and send them back to the user. We could do all that, but we're not going to, because firstly, because it'd be a bunch of work, and secondly, because it's much easier to use the Express module. So the Express module will handle all that hard stuff for you, and load up static files, and send them back to the user without you having to do all the fiddling around yourself. So I'm now going to introduce you to Express. So Express is a popular Node.js module, has a bunch of useful functions for creating web applications. So in the previous lectures on PHP, I talked about the mean technology stack. So there's what's called the LAMP technology stack, which is Linux, Apache, MySQL, and PHP. Now the LAMP stack has been used for many years, and it's used still probably ubiquitous within sort of web development kind of thing. PHP is still used in 80% of websites. So LAMP is a classic, if you like, but it's also a sort of slightly aging classic, and it's a slightly annoying classic to use. And many people now are switching over to the mean technology stack, which is what I've kind of covered both in this course, but I've certainly covered the mean one, which is MongoDB, Express, Angular, and Node. So I haven't given you much on Angular, but there's a little bit on that. Node we're covering now, Express we're covering now, and MongoDB you've had plenty of with coursework 2. So mean is has many advantages. particularly some of which are related to Node, some of which are related to the scalability and nice JavaScript integration of MongoDB. I'm not going to go into that huge amount of detail now, but Express is part of that main technology stack. And the reason it's part of that technology stack is because it makes it really easy to develop web applications that have like static content, as I've explained, CSS files, images, JavaScript, or whatever, along with web services. And the web services deliver the data from the database. So you can use Express to kind of combine these two things really easily. So Express is a sort of separate module. It's not part of the default Node installation. So we need to install it as an add-on module. And Node has a package manager, npm, which is presumably Node Package Manager. So to add on extra modules with Node, we need to use the Node Package Manager. Now on the portable version of Node, this is kind of easy. We just do Node Package Manager, npm, install, Express, and then /save. If you do that, it'll then just install it into the portable version of Node, and it'll all work nicely and easily. So I've already done this for the portable version of Node that's available on the course website. If you need to install other third-party modules or other modules for Node, then you do it in exactly the same way, and it should work fairly easily. On the standard Node.js, it works a little bit differently. What you have to do is create an application within an application, which is basically just a folder. Then we install all the additional Node modules into that application. And that means that you can then distribute your application really easily, and it'll have all of the extra modules that Node will need to make your application work. So what we do is first we create a folder, do make directory my application. We go inside that application folder, and then we need to initialize that folder using the Node Package Manager so that it can install all of the additional Node modules into that folder. So we do npm init, and this will ask you for a bunch of bits of information about your application, like name, version, this kind of stuff. And so once we've set up this folder as an application, we can then install Express into this application. So then we do npm install Express save. So it's similar to this one, except we've had to mess around with creating this application folder and initializing that and then installing into that application folder. So this is my command line, showing you how it's done or how I did it. So we created this demo app folder. Okay, we went into this folder, we initialized it using npm. So I initialized, everything's on the path, so that's why it all works. So we initialized the folder, and then we had a bunch of questions like package name, version, description, get repository, keywords, author, and so on and so forth. So I just press return to get through all that stuff, and then it's generating a package JSON. This is like a JSON file containing all the information about the application, and then a few warnings or whatever. And then I installed Express into that folder, into that application folder. And then it's sort of recommending that I should commit this file to the repository and so on and so forth. And then at the end of this, which isn't particularly painful once you know what you have to do, I had my application folder and Express installed into that application folder. Now, if you flick through some of the tutorials, you may see that there's other modules that people often use in conjunction with Express. So you have things like body parser, we can handle JSON, raw text, and URL encoded form data, cookie parser, Malta, and you just install these in the same way as Express. So I haven't needed to do these to install any of these modules for the examples in this lecture. If you need to install them, then you just install them in the same way that I've just described. So I thought I'd start with a hello world with Express. So you can just see the differences between that and the standard sort of built-in HTTP module. So we have Express require, so same thing with any of these modules, we need to sort of import it into our application. So and that returns this object here, and in fact it's not an object in this case. Express is a function. So we execute the Express function, that returns an app, and then the app has all of the objects, all of the sort of data and methods that we need to run our application. So similar to the HTTP module, I'm going to define a function that's going to handle GET requests in this case. And I'm going to set up the application to handle the, so I'm probably going through this already. So I'm going to set up the application to handle the GET requests that are sent to the root tree. So here I'm specifying a path, and I'm specifying a function that handles GET requests that are sent to this particular path. So if I send a GET request to the root of the application, it's going to execute this function that I've specified here. And then, as usual, I'm going to listen on a particular port. So it's slightly different from the HTTP module, but not that different really. It's different in the sense that I'm specifying a path, and I'm specifying also a method. So I can split my functionality. I can have a different function to handle the post requests and different function for put and so on and so forth. So I'll give you a little demo. So where's my... So now I have to be sort of inside my demo app. All the other stuff that I showed you was, didn't have to be inside this folder, but the demo app, anything that's using Express, I need to run within my demo app folder. So here we have demo app. Here we have my Hello World Express demo. I'm going to run it here. Wait a minute. Now we've got. Yeah. So I'm running the. I've got a port that's already in use. So you get this error if you've got another application running in the background, right? So that's stopped now, I think. Hello World Express demo. Let's try that. Yeah. So it had a port conflict because I had the previous example running. So now it's running. Let's just see, see what we got. So if we go to Hello World, so if we go to the root of the application, we're getting Hello World. Now, probably won't work if we go to cats or whatever. That's not working, right? It's not working because I've only configured Express to handle get requests sent to the port of to the root of the application. So then we get the Hello World back, just as expected, really. Now, what Express does beautifully is it enables us to serve up static files with a minimal amount of work. So to do this, all we have to do is create a folder that holds the static files. It's better keeping our static files separate from our scripts that are actually used on the website, and also for security reasons, there's good case for that. So we're going to have a separate folder that's going to hold the static files. We're going to configure Express to use this folder, and then it'll just magically serve up all the files from that separate folder. So this stuff's the same, and to actually configure out this, so we've got to create a folder called public, and we just say app.use express.static public. That's all we need to do to serve up static files with Express. So in this little demo, so using this is the sort of the script, and what I've got here is a file called static-demo.html. It basically just contains a single piece of single HTML page, very simple. But also to show you, how it all works quite nicely, is we've got like a file called mystyles.css, and this static demo HTML file is linking to this styles file here. So it should change. So if it's working, it's got to serve up both this file, and then it should also serve up this file. And if it's working, then the H1 text should be changed to red because this is specifying that it should be red text. Yeah. So let's just show you that working. So where's my static demo? Static files express demo, there we go. So I need to stop whatever's running. And then as you can see, it's like 1, 2, 4 actual lines of code. I import the module, I get the app, and I specify that the app should serve up static files from my public folder. So in my file structure here, I've got, I'll just show you this on the systems, and then we've got some code. So here we've got my demo app, right? This is the folder that I've kind of created and initialized with my package manager, and that's got all this stuff with the node modules and the rest of it, all the complicated stuff. But it's also got a public folder here. That's the folder I've created. Inside this public folder is my static demo and my styles, which the Express is going to serve up for me. So now, with a bit of luck, we can go static demo HTML. So now I'm requesting the file static demo HTML, and it's, with a bit of luck, what's going on here? I'm not actually running it. Okay, so let's run it. Okay, so now it's running. And if I refresh it, then I can see hello from static web page. So it's serving up both static demo HTML and mystyles.css. So it's serving up that file and the file. So serving up this file and the file that it links to, which is this file here. Okay. Right, so the next thing I want to cover is web services. And if you're building a single-page web application with Node, you're almost certainly going to need web services. So to clarify what I mean by web service, I'm going to make a distinction, clarify the distinction between websites and web services. So websites are designed for human viewing, right? It's a bunch of images, CSS, etc. they look pretty. So if we have a weather website, the user views the weather website in a browser, and the browser does the hard work of sort of organizing all the sort of HTML and the CSS and the images and arranging them on the page as specified, and handling interaction from the user and so on and so forth. So a website is designed for human viewing, and it typically has CSS and images and HTML and so on and so forth. A web service, so both a website and a web service are running over HTTP, right? So this BBC website, you're sending an HTTP request to the BBC server here, and it's replying with some HTML, and the HTML links to some CSS and links to some images, and it's again using HTTP to pull those CSS and pull the images and load them into the browser and display the page. Okay, it's all HTTP in terms of communication. Web services are also HTTP, but the aim of a web service is to provide data in a format that computers can understand. So instead of providing it in a human-readable format, it provides it in a computer-readable format, and these days it's typically JSON. So, 10, 15 years ago, whatever, XML was all the rage, everything was delivered in XML, but XML is kind of clumsy to parse, and it doesn't work very well with JavaScript, and it's quite sort of bloated sort of way of sort of wrapping up data, whereas JSON is sort of super compact and efficient, and very easy to move, and it's very easy to move between JSON and JavaScript, as you'll know from your coursework. So web services these days typically provide data in JSON, and they often form part of the back end of a website. So your website might serve up some static files like the CSS and the images, and then the dynamic content, in many cases will be served up by a web service using JSON as the data format. Web services are also used to share data with other people, sometimes for a fee. So you might have like a stock information web service, or you might have a weather web service, or lots of other football results web services, and so on and so forth. If you want to provide data for other people to use, then this is a very typical way of doing it. So this is like a weather web service. As you can see, it's got the weather information, so it's the same information as this BBC site, but it's in a very different format. And then a computer could, pull this, go to this URL, get this data, and then use that data, in someone else's website, or for some other application like a app or something like that. So that's a web service. Now, if you sort of one of the standard ways of using web services to deliver data is what's called a RESTful web service. It's a standard way of using the HTTP methods get, post, put, and delete to access and change resources on a server. So, for example, you could use the HTTP get method to read a resource. We can use the HTTP get method to put or to insert a resource, add a new resource. Post could be used to, I think it's the other way around actually, but we could use post to create a resource, use put to update a resource, and we can use delete to delete a resource. Now, there's a little bit of ambiguity about which way around post and put should be used, but think of it this way: post, you could think of posting a letter or creating a new resource, and put as a way of putting some new data in a resource that already exists. The exact fine details of this aren't super important. It's all about having a standard way in which you can use these methods combined with the identifier of the resource to manipulate the data on a database, or, typically on a website running somewhere or other. So this is sort of a little bit example of a RESTful web service. And by the way, there's lots of jobs, that are looking for people with skills in RESTful web services, so it's a very useful skill to have. So if we're using get, we want to access the resource. So in this case, the URI here is the universal resource identifier, and the URI can in many cases just be the URL. So remember we had all that stuff on the path a little early in this talk. So in this case we can use the path of that's being sent to the server to control which resource we're manipulating on the server. So if we send a get to this URI or URL, we can get a list of the users. And if we want to get an individual user, we could use like user service /user/1, where 1 is the ID of the user. So we could get an individual user, or we could get all of the users, depending on the URL, the path within the URL. And then we can use put and post. I think it's slightly the wrong way around here, but we could use post with a particular ID to insert or update a particular user. I think insert is the more typical usage. So if we do a post message to users with 2, ID 2, we're inserting a user and specifying the ID of that new user should be 2. And if we do put, we can send some new data to change whatever data there is already stored under the ID of 2. And delete, same idea, right? If we want to delete a particular user with a specific ID, we could send a delete message with the ID of the user we want to delete, or we could send a delete message to all of with the URI being users in general, and then that would delete all the users. Obviously, a rather dangerous thing to do, but you get the general idea. So this is a RESTful web service. We're basically using the standard HTTP methods to manipulate the data, and what data we manipulate is specified by the URI here. So, just to illustrate that, I'm going to show you how you can create a very simple web service with Express. In this example, I'm going to use a JavaScript object as my data. In a real website, the data is going to be held in a database. So, in this, this is only an introduction to Node. It's a kind of an advanced project, so I'm only going to show you how to use get. But post and put and delete, work in a similar way, and I'm sure you can figure that out for yourselves. So in this very simple web service, we've got /users is going to return a JSON formatted data of all of the users, and if I do users/user ID, it's going to return JSON formatted data of a user with this specified ID, and all other URLs are going to return error. So it's very similar to these two bits of the web service here. So this is my Express web service. So I'm going to start with the sort of first half of this. So it's the standard stuff. I'm going to require Express, but I'm also going to use the URL module so that I can extract the path. I think I handle the path. Maybe I don't. Well, not in this bit anyway. Anyway, we definitely need the Express module. So standard stuff, the app. And then here is the crucial bit. Here is our data structure. So obviously this data structure could be a data structure on MongoDB. But in this case, because it's just an example, my data structure is going to be a JavaScript object, that's hard-coded, here. So we have like a bunch of 3 users. Here are the user IDs here, and then the user IDs point to another object here with a bunch of key value pairs containing data relevant to these users. Now here, I'm setting up my application to handle GET requests sent to the user path. So here I want to send, if the URL contains users with a slash and then any old subfolder, I'm going to call this handle get request method, and I'm also going to call this handle get request method if I just get a URL a path that just has like users with no subfolders. So the star thing here says that there can be other stuff after this part of the path. So all of my web service requests I want to send to this handle get request function here, and that's the function I'm going to describe here. Here's my handle get request function. So to start with, I'm going to get the in fact, I'm not even doing query string stuff here, so that's why it's not using the URL module. I'm just getting the URL here. That's the request has the URL field, which is the entire URL, and I'm splitting it using standard string methods to get out all the different pieces of the URL. The next bit, I just want the last part of the path. Remember, I'm either going to have /users, which will provide all of the users, or I'm going to have / a particular user ID. So really, to make this web service work, all I need is the last part of the path. Obviously, with a more sophisticated web service, I might need to do a better job of that, but in this case, it's very simple, so that's all I need. So path end is either going to be a particular user ID, or it's going to be /users, which would mean I want to return all of the users. So if this path end is users, I'm going to send. Remember, data here is my data structure. This is my data structure here. So if the path ends with users, I'm going to send all of the data back. I mean, in a real-world application, I'd probably just send back the user IDs, but for simplicity, I didn't see the point in doing that really, so I just sending back the whole data set. And then otherwise, if the path ends, so if this path end, the last part of the path, is in data, this is checking to see if path end is one of the keys in data. In other words, if it's one of the user IDs. So if the path end is in data, i.e. it's one of the user IDs, then I'm going to send the data for that particular user. Otherwise, if the path's not recognized, I'm just going to return an error message, also in JSON format. So here's my web service. If I go to /users, it's going to return the data from all of the users. If I go to user 1, it's going to return the data for user 1. If I go to user 5, it's going to give me an error. If I go to user 3, it's going to return the data for user 3. So it should be fairly straightforward, I hope. So let's go for find my Express Web Service demo. Why is that inside public? Good question. Let's run it anyway. Probably shouldn't be inside the public folder. It seems to be running anyway, so let's just go for it. Alright, so that's probably going to give me, can't recognize it right, so if I go users, great, yeah, so it's working. So if you have users, it's replying with all of the users within this in my data set. And if I do like user 1, it's replying with Brian, who's the first user. If I do user 4, doesn't recognize it. And if I do user 2, whatever, then it's replying with the data from user 2. So here's the URI, or the sort of the identifier. This is a particular ID of my user, and then this is the whole URI, right? I'm saying I want to access the users, and within the users there's one called user 2. It's a very simple RESTful web service without all the updating and modification stuff. The get part of a very simple RESTful web service. Right, so now I can bring all this together. I've shown you how to build a very simple web service. I've shown you how to serve up static files, and now I can show you how you can build a very simple single-page web application. And so I haven't bothered putting up the example code for the previous examples, but the example code for this simple web application is available on the course website, and you're very welcome to use or adapt that, take that as a starting point for your own sort of web application for coursework 3. So as I said, combining statically served files with a web service. The web service is identical to the one I've just described, so I'm not going to go into any of the details here. I'm just going to explain the differences and the bits that I had added on to make it all work. So what I've got is I've got some client JavaScript that requests a list of all the users from the server. Okay, so we've got the web service that provides all the users, and I'm going to have a bit of JavaScript on the client side that's going to request that list. Then this client JavaScript is going to build a combo box that contains all the user IDs, and then when the user selects users from that combo box, the client-side JavaScript is going to request the data for that user from the server. That's how it's going to work. So, as you can see here, we're going to the root of the application, and it's currently showing user Carol. If I select user 3, then it loads up the data for Sue. So this combo box contains all of the IDs from all of the users, and then the user can choose which data it views, and when it makes a choice, the client JavaScript is requesting that data from the server. So we've got a number of components to make this work. We've got a static HTML page, index.html, and all that has is links. It's empty apart from some links to the style sheet and the JavaScript files. We've got our style CSS document file. We've got a client.js. This is the JavaScript that's going to run in the browser and communicate with the server. And then we've got our server.js. That's the JavaScript that implements the web service on Node.js, and also sets up Express to serve up the static files. So index.html, it's not a complicated document, right? We've got our links to the site CSS and links to the JavaScript. And in this case, let's keep it clean and simple, I guess. I decided we'd add the page contents entirely by JavaScript. So it's completely empty body, but we're going to fill that body using JavaScript manipulation, the document object model. Then we've got style CSS, so nothing very fancy there, but just to show you how you can add some styles to it. And then on the server side, everything's identical to the web service example, except here I'm configuring Express to serve up static files from the root of the URL. So it's the root's the default. So I've got my web service here. So whenever I go to users, I'm going to call this function handle get request. Whenever I go to the root of the URL, it's going to serve up, it's going to go into the folder public and see if it can find an appropriate HTML or CSS or JavaScript file to return in response to the request. Oh yeah, and here we go, right? Yeah, so everything else is the same. except that we're configuring it to also serve up static files. So we can get that index HTML and the CSS and the client JavaScript served up to the user. So client.js is one of the static files that's served up, and its first thing it's going to do is set up the page. So we have a combo div and a data div. So the page is completely empty, as you remember, completely empty body. And so what I'm doing here is I'm using the document object model methods to kind of create elements and add them into the page. So my combo div, I'm just going to create a div element and a date div. So the combo div is going to hold the combo, drop-down combo box. The data div is going to hold the data from the user. So I'm kind of creating these elements dynamically, and then I'm adding them into the, and I'm putting a header on, just making it all nice and pretty. And I'm basically getting getting a reference to the body, and I'm adding, the header and the two divs into the page. So I'm sort of dynamically building up the page and filling that empty document body. Once I've put in the combo box and the data divs, I can then load in the list of the users. So by calling this load user list method. What load user list is doing is it's sending an XML HTTP request to the server, and it's requesting all of the users from the server. So you see here we've got the path. We're sending a GET request, and this is being sent to all of the URL, all of the users. So in this case, it's going to return all of the users back to the client-side JavaScript, and then we're going to get and this in JSON format. So I can then use JSON.parse to convert all of the data that's been sent back from the server into this data object. This data object will contain the keys of all of the users. So, as I said, in a more stripped down version of this, I would just send the keys as it happens. This data object contains everything, but for this example, just sending back all, just going to use the keys at this stage. So here, I'm going to build a combo box that contains the IDs of all of the users. So here we have building up the combos, going to give it an ID user combo, and then for each of the keys, I'm going to put that as one of the options in the combo box. And then I've got this combo div. Remember, I've set up this combo div in the previous page. So the combo div, I'm going to add the combo box to, so the user can actually see it. And then finally, so that's the list of users. This function load list of users. The final bit, I'm going to load up the actual data from the selected user. So whenever the combo box changes, it's going to call this function load user data, and then we're going to get out the user ID that's been selected. And then we're going to send another XML HTTP request to the server to request the data for that particular user. So in this case, we're sending the URL is users / the ID of the selected user. So if I did users, user1 or whatever, it's going to send back the selected user ID. So this is requesting the data for a particular user, and then all it's doing is just loading that data, which comes back in JSON format into the page. So I'll give you a little demo. So let's so hopefully, wait a minute, let's start it. Obviously, so we've got server.js. That's what we want to get running here. So let's run server.js. Yep, seems to be running. Great. So now we go back to here. Now let's just go back. So let's just show you the basic thing. So here we have. This is a dynamically generated web page. We've loaded. This is the combo box containing the IDs of all the users on the server. Yeah. So if we go, and then when we change the selection in the combo box, like user 3, it's sending an XML HTTP request to the server and pulling back the data for Sue in this case, or pulling back the data for Carol, or pulling back the data for Brian. So you can see it's a single page web application, and it's using a RESTful web service to deliver the data from the database. And if we wanted to change this data, it would work in exactly the same way. We'd have a web service when we send a post method with the appropriate update methods with the appropriate revised data or whatever it was in order to manipulate the data on the server. But you can also see, I hope, that the web service is still alive and kicking, right? We can still see the web service here. We can see users. Here's the web service for all the users. You want to see users, user 1 or whatever. That's all still working, but we're combining this web service with this serving up of the static page and the static JavaScript, which statically serves JavaScript, and that JavaScript's then providing the front-end functionality for the website. Okay, I hope that's pretty clear. I'm giving an example code anyway, so the best way of really understanding it after you've watched this lecture is having a little look at the example code. You can just download it from the course website here. There's a bunch of resources I put on, so There's quite a few sort of free books on Node. There's like a Succinctly book, various books on various tutorials on Node and Express. Have a little look at those, work through some of the examples, and and I'll give you some support on that on the labs, obviously. Okay, so this lecture I've introduced you to Node.js and Express. I've shown you how to build a simple single-page web application. So I think that's enough to get you started on coursework 3 with Node. So the next lecture I'm going to show you how you can use JavaScript running on Node.js to manage data on a database. So you're going to basically explain how you can use the JavaScript methods to then pull out particular data from a database rather than just from a data object. And then you can build a web service that then returns appropriate bits of data to the user and maybe supports updating as well.